All right, let's take a look at example 3. In part A, we want to determine the end behavior, so let's identify the leading term. By using the lead coefficient test, we can find the end behavior. So the lead term is x to the 4th. All right, so n is equal to 4, and that is an even degree. So either falls left and right or rises left and right. A sub n is positive. That's great. A sub n is 1, it's positive, which implies that with an even degree with a positive coefficient, we're looking at the behavior of something like y equals x squared. And y equals x squared looks something like this. So based on that, we can say that we're going to rise on the left and rise on the right. Part B, we've got to find the zeros and state the multiplicity. All right, I need to factor. So I see that x squared can be pulled up front as the greatest common factor. So that leaves x squared minus 6x plus 9. All right, peeking in here at this trinomial, it's quadratic. I can go back to my previous knowledge. I can use a factor sum chart. And when we do, what happens is we get x minus 3 and x minus 3. Notice that x minus 3 occurs twice. So x equals 3 will be a 0 with multiplicity 2, and we'll just touch the x-axis. All right. So set each factor equal to 0. The 0 that results here is x equals 0, but multiplicity 2, because of the square here, and we touch. And then I'll only do one of these. X minus 3 equals 0. Add the 3 to the other side. X equals 3, but it occurs here also, so multiplicity 2. We're also going to touch at that 0. So no crossing on this graph. All right, I think I'll put, well, I guess I'll put C right here. I think C is the y-intercept. So every x is made into a 0. Well, that's easy. If that's 0, that's 0, and that's 0, again, the answer is going to be 0. So the the y-intercept is the origin again. Plot additional points if we need to. Let's go ahead and get the graph going. All right, I have zeros of 0 and 3, and that's it. So I put those on there first. This is 3. These are the only 2 x-intercepts. Then I look at the end behavior and I go, oh, okay, it rises left, rises right. So I know the graph to the left of this furthest left x-intercept has got to come off this x-intercept and rise. And then also when I leave this last x-intercept, I've got to rise. So what's happening in between? Well, let's go over here. X equals 0 has a multiplicity of 2. So right here I can't cross. I'm going to have to actually just touch. So I'm going to have to bounce off, come back up above. Okay. At some point I'm going to have a turning point. So I've got 1 turning point, 2 turning points. Remember, at most I can have is 3, 1 less than the degree. As I come back here, because I've got to touch this x-intercept, I'm kind of looking over here at x equals 3. It has a multiplicity of 2, and so we have to touch. Well, that makes sense, because I want to touch and then leave, and then so that my end behavior is all intact and I'm rising on the right, it should look something like this. If you're interested in the y-coordinate here and the y-coordinate here, you could go to the function and plug in, say, x equals 1 or x equals 2. If I were to plug in 1 here, 1 here, 1 here, and here, I'd have 1 to the 4th minus 6 times 1 cubed plus 9 to the 1 squared. Well, 1 to any power is always 1, so that's 1. 1 to any power is 1 times negative 6. 1 squared is 1 plus 9. I'd add the 9 and 1 and get 10, and 10 minus 6 is 4. So if I needed to know another point, that's what I could do. So 1, 4, so 1, 4, so this must be 4 over here. And then you could plug in 2 if you wanted to kind of see where that point is, just to get a little more specific and tweak that graph a little bit more. But for what we're doing, that's perfect. A sketch is great. Just be careful with your placement of your powers. Like that square is not on the outside, it's with the x, whereas that square is on the outside of that entire factor. Okay, part A, lead coefficient. Okay, the lead coefficient is going to be a little bit tough because notice that this problem is already factored. Finding the zeros is going to be easy because we don't have to do the factoring, but finding the lead term is going to be a little more tricky. All right, so if I wanted to, I could multiply out 2 of these parentheses, get an answer, and then multiply it with this binomial, and then finally take all of that and multiply it by -2. But remember, all I want is what would be the term with the highest exponent. So we can kind of inspect this and predict what we think the lead coefficient or the lead term would be. Without foiling this, think about if you were, what would be the leading term? Well, if I were to multiply 2 of these out side by side, okay, I'm going to get x squared to be the highest exponent. So that's all I want to extract from this product, this multiplication. So I would have -2 times x squared that came from foiling here, but then I'm going to have to eventually multiply all of this, these terms, into another factor. So what happens when I multiply into this other factor, whose lead term inside here is x squared? Well, cleaning this up, I'm going to have -2x to the 4th. So if I were to do all that crazy algebra, my lead term would be -2x to the 4th. So n is 4. That's even. A sub n is -2, which is less than 0, negative. So all of this means that we want to have n behavior on this graph that looks like y equals -x squared. Even, we go back to that first page. All right, we want an even exponent. Well, that rules out these 2 cases, and we want a negative coefficient. So falls left, falls right. All right, now the beauty of this problem is that when we find the zeros, it's already factored for us. All right, now you could factor this into x plus 5 and x minus 5, or you could use the square root property. I think I'm just going to go ahead and use the square root property. So at each of these factors, we set them equal to 0. Well, that's a fake statement. That's false. So no zeros here. Notice that I have 2 of these same factors. I could bring in the square root, but when we finish doing all that work, we're just going to get x equals 4. But we know that because we have 2 of the same factors, it's a multiplicity of 2. So we touch the x-axis. All right, set this factor equal to 0. Now you could add the 25 to the other side, bring in the square root. Remember, square rooting and square power brings out the x, but with absolute value. Square root of 25 is 5. Remove the absolute value, and we have 2 zeros. And they each occur only 1 time, so the multiplicity is 1 on each of these, and we're going to cross. Okay, part C. We're finding the y-intercept. So let's go back to the original equation. So I see -2, I see 0 minus 4 squared, and I see 0 squared minus 25. So this is not as easy, but that's okay. I probably will do this power first. So I've got -2 times -4 squared is 16. 0 squared minus 25 is just -25. So, multiplying that out, I want to say that's 800. Holy smokes. So the 0.0800 is your y-intercept. Wow, that graph goes up high. All right, so I guess I don't have much room, but I'll use this room right here. What are my zeros? -5, 5, and 4. Okay. So maybe make my tick marks a little bit closer together here. -1, -2, this is -5. This is 5, and then I need 4 as well. So I've got 4, -5, and 5. Yep. Those are the only 3 x-intercepts. Okay, now I think along, gosh, the y-axis, when I think about the y-intercept 800, 1, 2, 3, 4, 5, 6, 7. Yeah, I'll count by hundreds. So at least label 1 tick mark so there's a suggestion of what that scaling is. So 2, 3, 4, 5, 6, 7. This is 800 right here. So I know I have a y-intercept there. Okay. I mean, in reality, if you scaled it the same, that thing's going way up there. Okay, and behavior, falls left, falls right. Okay, so furthest left x-intercept, you can put those ends in. Okay, let's take a look at x equals -5. We're going to cross. The next x-intercept I have to get to is here, so it looks like this graph's going to have to come way up here. Now, I might go past it, and that's fine. I need some additional points, but at this point, I really don't care. Turn around. I've got to hit this first x-intercept at 4. Okay, but what happens at 4? Come back over here. I'm going to touch. So I've got to bounce off of it, but then real quickly turn around, another turning point, so I can pick up that last 0 and then continue on downward. Kind of a weird graph, but just based on the information we found, that's what it would look like. All right, so I hope this helped.